Welcome, Algebra class. Today we're going to do another fun-filled lesson where you can sit back and just learn, and I can cram your brains full of information. Last time that we talked, or that I gave a lesson, it was on substitution. And if you have two different equations with two variables in them, you can of course use substitution. I could solve, like I could leave the y there, move that over, and then y equals 4 minus 2x. Everywhere where I see y, I could put that in there and I could solve it. To me, there's another method that's a little easier, and most of the time it's easier. This is called elimination. Why don't we go through it right now? Let's say I had these two equations. Our problem with solving with these two equations is that we have too many variables, right? We've got an x and a y. Now, luckily, we have two equations, so we're able to solve it. But there's a way that you can work with these two equations to make one of the variables just drop away. Do you see that if we simply line them up, x is above x's, y is above y's, numbers above numbers, and in this case, if we added, do you see that the y's are going to just drop away? Just stop for a moment and just see if you can see that. If we simply add 2x plus x, just make a big plus out there, 2x plus x, we're going to get 3x. If we add positive y and negative y, it goes away. And if we add 5 and 4, we get 9. Now we just need to solve x equals 3. And once you have that, all you have to do is go back to either one of these equations and stick it in there. So let's just put it in here. We'll get 3 minus y equals 5. So what I'm going to do, I'll just write that down here. 3 minus y equals 5. So I'm going to move the 3 over. So the opposite of y, can you still see this? Yep. Equals 2. So that means, therefore, if I divide by -1 now, y equals -2. So my point is 3, -2. Remember, that's the point in space where these two lines are crossing. The other way to think of it is this is the x and y that make both of these true at the same time. So 3, -2. So do you see how elimination helped us there? I personally think that's a bit easier than substitution. What if we did it a little different way? Do you see that the x's aren't going to just cancel out, but I could make them so that they are going to cancel out? And this is actually tomorrow's lesson, so I'll give you a little bonus here. If I have this equation down here, remember that I can multiply everybody by the same thing, and it's still going to be an equation. It's still going to be equal. So what if I just multiply everybody down here by 2? I'll get 2x, I'll get 2y, and instead of 5, I'll have 10. Now, do you see how that helped us? The y's are no longer going to cancel out, but the x's can cancel out. They're not going to cancel out, though, by adding. That would give you 4x. So we're going to subtract everybody down here. 2x minus 2x goes away. Y minus -2y is going to give you 3y. And 4 minus 10 is -6. Divide by 3 this time. Y equals -2, which we already knew because we solved it in the other way. Now that you have y equals -2, why don't you just stick that right there? Get rid of that so it doesn't confuse you. 2x minus 2 equals 4. So move that to the other side and add it. 2x equals 6. Divide by 2. X equals 3. And we already knew that, 3 -2. So do you see that you can manipulate these equations in different ways? If you want to, if they don't naturally just match up, you can make them match up. And then you can either add or subtract to get rid of one of the variables. That's all elimination is trying to get rid of one of the variables, solving for the remaining variable, and then putting that number back in one of the original equations and getting the second variable. Okay, I hope that made sense. All right, go back to relaxing.